Hello, my name is Dr. Simon Schmidt. I'm head of the Department of Hygrothermics at the Fraunhofer Institute for Building Physics IBP. And I welcome you to the fourth video in the series of the Lighthouse project in RAJKOT about the monolithic concrete construction using tunnel formwork. In this video, we will look deeply into the durability optimization of that construction. Within that video, I will show you some basics and backgrounds about durability evaluation methods, and we will go deep into the construction itself, looking what kind of durability problems can occur and maybe will occur, and what can we do about that. Starting with that, I would go first into the influences of the climate on the durability of the construction. Climate is one of the things that are most severe to our construction, and we will see that depending on the climate that we have on the outside, the different construction act differently. So it's necessary to look at the climate itself and see what kind of differences there are. In this video, we will look at the climate in RAJKOT and see what the influence of that climate could be. The climate itself in RAJKOT, which is on an altitude of around about 134 meters above sea level and has a mean temperature of 27.2 degrees and a relative humidity, mean relative humidity of around about 57.9%. What you can see on the right hand side are two graphs, one for the solar radiation, and the blue part is indicating where the most solar radiation is coming from, and this is coming from somewhere in the south, over the central, which is with 3,532 kilowatt hours per square meter and year, quite high. On the second graph you can see where the rain is coming from. So we do also look at the rain, because moisture is a major problem within the durability of constructions, and we will see that the main rain area is from the southwest, and we can see also on the left hand side that with 676 millimeters per year the rain is not too high, but if I add that this rain is coming just in some month, then that is quite high. So one aspect will also be the rain protection on the outside. That is the one hand side. On the other hand side, we have to look at the materials itself, and there are different material properties that we can look at. I've just brought some of them for you, which is the heat conductivity. This is measured in some device, as you can see here, and it gives you the amount of heat going through 1 square meter of a building component at 1 Kelvin temperature difference between inside and outside. With this, we can say how the temperature stress and what is happening there, and we can calculate what is happening within the construction itself. A second thing that we can test and where we can see how the material behaves is a so-called thermal stress test, where we put the materials under artificial lightings. We stress them in terms of temperature, temperature on the outside, temperature differences between the outside and the inside. We look at cracks that occur, and we see how the behavior of that material is in that area. And the last thing that I've brought to you today is the so-called radiation characteristics. So we measure also the surface and the color of that material, so that we can, for example, find out the emissivity. We measure that, as you can see it here, for different materials, and see what is happening then. So we can see the reflectance, we can measure then the absorptions, and if there is an opaque building component, we can also measure the transmissions. This we have looked at deeply into the video with the video 2, where we look into heat and moisture transport also for RAJKOT. If you haven't seen that, I would invite you to look at that. So what we have looked now is on the outside component and on the material itself. And now is the question, what happens with the material itself if this stress is on it? What could happen? What could the outcome of this durability measures be? On the one hand side, there could be mold growth on the inside or algae growth on the outside. We normally say that high moistures above around about 80% relative humidity are good for growing. So mold can occur and also algae on the outside can occur. And also moderate high temperatures are beneficial for that growth. Second point, if we underrun the dew point on the construction surface, inside, outside, but also on the conjunctions between different materials, we will have condensation. Condensation can occur more or less everywhere in the building construction, and we will have the problem that with that moisture, the risk of, for example, corrosion, which also needs a high relative humidity and the availability of oxygen, which is mostly there, can occur. But also on the other hand side, mold growth can occur because the water is going through places where it should not be. This for the basics of the durability and the consequences also out of it. If we now come to the construction that we have in RAJKOT, where we have the monolithic concrete construction, which is in place built, we have mostly concrete construction. So I have put on some concrete construction, as you can see here on the right hand side, a concrete wall with render on the inside and the outside, and I have calculated the moisture content within this construction over a whole year. What you can see here is the relative humidity between 60% and 100%, and you can see the red line, which is the beginning of the calculation, and the blue line, which is the end of the calculation. What we see here, that to the inside the relative humidity is quite low, so there should be no problem in terms of mold growth or other problems in that area. But on the outside, we have a quite high relative humidity. So this is the place to look at. And we can do that by, for example, plotting all the dots onto a screen, which can look like this, where we have the temperature here, so the surface temperature, and the relative humidity up here. And what we see is that there's a quite span of points that we have, and the dark points are the end of the simulation. So that what is blue here is also black here. And then there are two lines in it. These two lines indicate where mold or algae growth can occur. So in that area we have a broad span and high temperatures and high humidity where we have the possibility of growth on the outside. So this is the basic construction. A concern from my side would be that we have growth on the outside, that we have also, if there is high moisture on the outside, if there are cracks or something, we have also corrosion on the construction itself, and as it is a concrete construction, that could occur. So we have to do something about that. If you have also watched the video 3, where we go into the energy efficiency measures, you will have seen that we have tried to put a white surface on the outside in order to enhance the energy efficiency. So that is what I've done here also to evaluate what is happening then with this basic construction if we put on a white surface on the outside. What you can see here is that if I put a white surface on the outside, the temperature is not that high, so the points run more to the left, but it's still wet. You can see also that it's still wet here up here on the outside. The inside is still dry, but the outside is quite wet to a depth. And you can also see there's still a wetness on the surface, and this is due to possible growth on the outside, but also due to possible corrosion on the outside. Not good. The next step would be maybe to put an insulation onto the surface. So what I've done now is put an insulation on the outside, and hopefully it's getting better. So let's do that. If we put an insulation on the outside, you see that for the construction itself, on the outside itself, the utmost problem that we have is still that we have very, very high and even higher than before moisture on the outside on the plaster that we have here. But what we also see is that due to the reduction or the insulation that we have here, we have a quite high reduction on the construction itself, which you can see here on the concrete. So there should be no problem about corrosion within that area. But also on the outside we will have problems with growth on that side, because a lot of points are up here, still up here, and that is the problem that we have. If we change that from an outside to an inside insulation, maybe there's a possibility to enhance that and to reduce that amount of moisture that we have. What we see if we do that is that still we have high moisture on the outside, and we still now have also high moisture on the construction itself. So the corrosion can happen again, even though it's not better on the outside in terms of mold growth. So what we can say is that bringing a white surface here, which is good for the energy efficiency, might not be too good for mold growth, or mold growth which should not happen. What we also see is that an outside insulation is better than an inside insulation in terms of corrosion on the system itself. And we will see that there are other possibilities that we can use. In the next video, where we look at the comfort from the outside for the inside, you will see also another thing in terms of outside and inside insulation, which has to be taken into account. So it's not so easy to say it's good for the energy, so it's also good for durability. It can be both, but in this case it's good for the energy, but it's not so good for the durability. Summing that up means, on the one hand side, bright colors increase the risk of algae growth on the outside, which can be a problem, but must not be a problem. We have seen that insulation, exterior insulation, reduces the relative humidity in the construction, and therefore also the risk of corrosion within that. Also, if there are occurring cracks in the plasterboard, these cracks bring in some energy, bring in some moisture, but it is not too bad for the construction, as we have the moisture buffering zone of the insulation on the outside. But nonetheless, for all the construction that we have looked at, is that if we are using that bright colors, and if we are using whether outside or inside insulation, we have to look at the rain protection. So there has to be an intact, very good rain protection, so that we can be sure that there is no rain coming into the construction, and especially in that area that you are working with the monolithic concrete construction and the corrosion problem that may occur out of that. This rain protection has to be very, very good. And with that, I say thank you for today. Looking forward to seeing you in another video, maybe in the next one where we discuss a lot about comfort, maybe also in another one. Goodbye.